Hello, Yuan. So, in this video, let's talk about the problem 674, problem name longest, continuous increasing subsequence. So, the problem goes like this. You are given an unsorted array of integers nums, as you can see in the input here, and you have to find out the length of the longest continuous increasing subsequence. So, as you can see, subsequence is given as an array. So, you have to find out a subarray out of this bigger array that is the longest and which is like increasing. So you can see the example here that this is a nums that is as an input. So for this input, this 135 is the longest increasing. Okay, when you take 4 as in the input, it will decrease. Okay, so if I tell you an example, so it is one, next one is increasing, next one is increasing. Now, if you take this one is decreasing. So that is why this is the longest that is increasing. In this, as you can see, only two is increasing. You can take only one length subarray that is increasing, because if you take the next one, that is the same. So that is not strictly increasing. So the only length that is like you can say strictly increasing is of length one. So how you can do that? It's pretty much simple. As you can see, we just have to go over from left to right and check every element with its previous element. If this current element is larger than the previous element, then you can keep on taking that particular element in the largest subarray that you are building. Or else what you can do is that you will now remove the current element that you are taking because that is smaller, and you can now start the subarray from that instant only. Okay, I'll tell you with this example. So what you can see here is that let's say I have 1, 3, 5, 4, and 7. So the minimum subarray you can form is always 1. You can take always the very first element, and that can be one of the subarrays. So let's start with the second element. Compared with the previous element, that is perfectly bigger, so no worries. You can take this subarray. Take this. Okay, this is bigger from the previous element, so you can take this subarray. This is smaller. So this is smaller, so which means that this can be one of the possible candidates for a continuous increasing subarray. And now because this is smaller, you can now start your subarray from here. So this can be one. Now this is small, larger than this, so this can be one. Okay, so that is how you can see that I have made this one subarray and this one subarray, and this one is the larger length. So the answer will be of type 3. Okay, that is the complete logic. You just have to do it from left to right and find out whether the current element is larger, strictly larger than the previous element. Keep on increasing the subarray, and whatever the maximum subarray that you found out, just take out the maximum of it and just print out the maximum answer. Okay, so that's the complete logic for this particular problem. Let's see the code part of it right now. So yeah, so what we have done is that we have taken these variables such that this is the current maximum subarray that we are finding out, the length of the current maximum subarray that you are assuming that that can be the largest one. This maxi is the one that is storing the maximum among all the subarrays that you will eventually form. So you will iterate from the second element, that is I equal to 1, till the very last element, and you will then check that whether this current element is larger than the previous element. If it is larger, then you will keep on increasing your current, because which means that you're iterating from left to right and you find out that the next element is larger than the previous element, which means that it can be taken in the current subarray. So if it can be taken in the current subarray, you will increase the current by 1, and you will find out that whether this can form a potential maximum subarray. You will maximize it over all the possible subarrays. If this condition doesn't met, which means that it is smaller than or equal to, which means that you have to break your subarray at this point and have to start a new subarray. So you have to break the subarray, which means that now you are starting a new subarray, so your current will become equal to 1 again, such that you are now starting from this, the ith point at which you break, and this starts as a new subarray, and you will again keep iterating to take this as the new subarray starting point, and again like find out what is the maximum subarray you can form. In the end, you have the maximum subarray stored in this variable, which you can print it like this. And that's it. That's the complete logic. And what you can see here is the time complexity for this problem is O of n, because you're doing only one for loop from left to right. So this is time complexity. And the space complexity, as you can see, we're only storing, like you can say, variables only, nothing as an any extra space that you're requiring. So O of 1 is the time complex space complexity for this particular function, and O of n is a time complexity. Okay, cool. So that's the only logic and the code part for this particular problem. I hope you like the problem. I will see you in the next one. Keep coding and bye.